Welcome back to Mr. DuPage's classroom. This lesson is for my General Algebra 2 class. This lesson is 2.1, Graphing Quadratics in Vertex Form. The first thing I want to talk about is a parabola. What is a parabola? Well, that is what we get when we graph quadratics, or raised to the second power. A parabola is a U-shaped graph. As you can see, we have a picture of the St. Louis Arch here. That is, in fact, a parabola. Also down here on this lower picture, there are four parabolas, or half of another one there, with the windows on the bottom. That is what a parabola is. It is a U-shaped graph. Okay? So make sure you have your data up in the right-hand corner, and let's get to work. To plot the vertex, it is the highest or lowest point in that U-shaped graph. We use transformations based on the parent function. Y equals x squared is our parent function. It becomes y equals a times the quantity x minus h squared plus k. Don't freak out about that. The a is just in place of a letter, the h is in place of a letter, and the k is in place of the letter. If you remember from our transformation lesson, though, anything that is inside the parentheses, we will actually use the opposite. That is why that negative is there. That means x plus the opposite of h, or x minus h. Okay? So the vertex is going to come straight from that equation there. The first thing that we're going to use is the opposite of whatever h that we see. So our x value for our vertex will be the opposite of h. If it's a positive inside the parenthesis, we would use a negative h. If it's a negative inside the parenthesis, we would use a positive h. And the y value that we'll use for our vertex will be the k value. You'll see that in a little bit. It should be a little easier to understand here in a second. The next thing we want to look at, number 2, we want to draw a vertical dashed line through the vertex. This is called the axis of symmetry. Symmetry means that both sides are going to be the same. It should split the graph into two equal parts. Its equation will always be x is equal to h, okay? Or the x value we use for the vertex. What we want to do is we want to fill in a table of values with your vertex as the central ordered pair, or xy, in our table. So the x value at this point where we have the arrow will be the opposite of h, and the y value will be our k. From there, what we're going to do is we're going to add 1 to each box moving to the right, and then we will subtract 1 in each box moving to the left. Using those x values, we will be able to solve for our y. So we want to use 2 x values to the right of the vertex and 2 x values to the left of the vertex, as you can see in our table. Then we want to go ahead and graph our ordered pairs to get the entire picture. We want to find our domain and range. The domain is all of the possible x values, and the range is all of the possible y values. Since the domain is all of the possible x values, if we think of a u, and if it were to go on forever and ever and ever and ever, it's going to spread out across the entire number plane. In fact, it would be all real numbers. How we write all real numbers is what we call a double barred R. And the range is all of the possible y values. Well, since it is a u, there are times that we're going to have it be or have a high point in our u. And there's times we're going to have a low point in our u. So what we would do then is we would write our range as y is less than or equal to our k value. That is if I have a high point to my u. Or we would write it as y is greater than or equal to our k value. That is if we have a low point to our u. Okay? You can find this answer by looking at your graph and seeing which way the graph opens. Let's move on to the next page. So let's get into a problem. Problem number 1. What would our vertex be? Well, I'm going to look at this location for my x value. Again, we're not going to follow our sign in that situation, or inside of the parentheses. So it would be the opposite of -2, which would in fact be +2. For my y value, I'm going to look at this out here. And since it is outside of the parentheses, I will follow the sign. So my y value would be -7. Okay? The next thing is the axis of symmetry. This is just going to be x equals our x value from our vertex. So x equals 2 is our axis of symmetry. As soon as I find my axis of symmetry, I want to go down to my graph. X equals 2, we would go to 2 on the x-axis, which is 1, 2. I'm going to make a vertical dotted line at x equals 2. So our graph should split that, or that should split our graph perfectly in half. So now we have found our vertex. We found our axis of symmetry. The other thing that I want to do is, as soon as I find my vertex, is I want to graph that also on my graph. So I would go to x is 2, so there's 1, 2. Go down to y is 7, so 1, 2, 3, 4, 5, 6, and 7. And I'm going to make a large point there. For our table, we want to put our vertex in the center. Well, the center right now is right here. So my x value was 2, my y value was negative 7. Moving to the right, I'm going to go ahead and add 1 per box. So I'm going to add 1 here. 2 plus 1 would be 3. I'm going to add 1 here. 3 plus 1 would be 4. Going to our left, we're going to subtract 1 from my x's. So 2 minus 1 would be 1. 1 minus 1 would be 0. Okay? Now, how do I find my y values? Well, what I'm going to do is I'm going to take each one of my x values. So I have 3 as one of my x values. I'm going to take that 3 and plug it back into my original equation for x. Okay? How do I do that? Well, it would be y equals parenthesis 3 minus 2 squared minus 7. Well, what is 3 minus 2? 3 minus 2 is 1, so I'll have 1 squared minus 7. 1 squared is 1. 1 minus 7 would be 6. So my y value, when x is 3, is going to be negative 6. I'm sorry. I screwed that up a little bit. This is 1 minus 7, so that would be negative 6. Okay? And we want to do that for each one of our x values. So the next thing I would do is I'd put 4 in for x. Well, put 4 back in for my x value. Well, 4 minus 2 would be 2. 2 squared would be 4, and 4 minus 7 would be negative 3. Then I want to put, well, from here, I do not have to do any more calculations. You could go ahead and calculate 1 and 0 here if you want to, but it should, because x equaling 2 is our axis of symmetry, we should end up with negative 6 and negative 3. Let's go ahead and check that real quick, though. If I take 1 and put it back in for x, 1 minus 2 is negative 1. Negative 1 squared is positive 1. 1 minus 7 is negative 6. If I put 0 in for x, 0 minus 2 is negative 2. Negative 2 squared would be positive 4. Positive 4 minus 7 would be negative 3. So we are good at this point. From here, what I want to do is I want to take my table of values and I want to graph it, okay? So we already have our point 2, negative 7. I want to use 3, negative 6. Well, here is 3. Negative 6 would be right there. Since I know where negative 6 is, I could go back to x is 1 and y is negative 6. Then I can go to 4. I want to go down to negative 3, so it's negative 1, negative 2, negative 3 is right here. Then I can go to 0, negative 3. Well, 0 is there. Negative 1, negative 2, negative 3. And there is our graph with our large dots. Okay? From here, I'm going to go ahead and connect my large dots. This should end up looking like a U. It does. So we have graphed it successfully. The last thing I need to do is I need to put down the domain and range. Well, the domain, like we talked about just a minute ago, will be all real or a double barred R. And our range is going to be, since my graph is opening up, that means that all of my y values will be larger than or equal to my y value in my vertex? Well, the y value in my vertex is this -7. So I'm going to bring -7 down here. So y is greater than or equal to -7. All right. Problem number 2. I have 3 times the quantity of x minus 1 squared plus 1. So what is my vertex? I'm still going to look here for my x value of my vertex. I'm going to use v colon for you to tell me that it is my vertex. Okay? Do I use the opposite of -1 or do I use -1? Well, since it's inside the parentheses, I want to use the opposite of -1. So it's just going to be +1. Then I'm going to look here for my y value. Since it is outside the parentheses, we should follow it. So that is also going to be +1. Okay? The next thing is my axis of symmetry. Go ahead and write AOS for axis of symmetry. That's just going to be an x equals something. Well, it's going to be x equals my x value of my vertex. So this would be x equals +1. Remember, once I have found my vertex and my axis of symmetry, I want to go ahead and plot those points. Well, 1, 1 should be right here. I need a vertical line at x equals 1, and it needs to be dotted. So here is my vertical dotted line for x equals 1. Now that I have plotted my vertex and my axis of symmetry, I want to go ahead and make my table. I'm going to put my vertex right in the center, which is here. So that is 1, 1. I need to add 1 as I move to the right. So 1 plus 1 is 2. 2 plus 1 is 3. I will subtract 1 as I move to my left. 1 minus 1 is 0. 0 minus 1 is -1. Okay? The next thing I need to do is to figure out my y values. I will do that by taking each x value and plugging it back in for x in the original equation. So I would have y equals 3 times, what is the first x value to the right of my vertex? Well, that is 2. So it would be 2 minus 1 squared plus 1. Using order of operations, or PEMDAS, I need to work through my parentheses first, then my exponents, then multiplication or division, and then I will add or subtract. So what is inside my parentheses is 2 minus 1. So I would have y equals 3 times 2 minus 1 is 1. That is raised to the second power, and then I would add 1. What is 1 squared? Since the next thing I need to work with is my exponents, that is also going to just be 1. So I'd have 3 times 1 plus 1. Well, what is 3 times 1? 3 times 1 would be 3, plus 1 would equal 4. So I'm going to put 4 right underneath my 2. Now I need to go back and take my 3 right here and plug that in for x. So I'd want to go ahead and erase this. And guys, you can do this all with your calculator. I do not need you to write this out. But if you do know how to write it out and you would like to, that is perfectly fine with me as well. So y equals 3 times what goes in for x? That is 3 minus 1 squared plus 1. So all I have done is taken my 3 from my table, plugged it back in for x, and now I need to solve it. Again, order of operations, I need to do what's inside the parentheses first. So it would be 3 times, what's 3 minus 1? Well, that's 2. That's raised to the second power. Again, according to order of operations, I now need to use the exponent. So I would look at the 2 squared. Y equals 3 times 2 squared is 4 plus 1. 3 times 4 is what my next step according to order of operations would be multiplication or division. So I'd take 3 times 4, which would be 12, plus 1 would equal 13. Okay, so that would go right underneath my 3. And because I know that right here is my axis of symmetry, the spot to the left will equal the first spot to my right, so that would be 4. The second spot to my left would equal the second spot to my right, so that would be 13. Now what I need to do is go ahead and plot those points. So the first point I'm going to plot is 2, 4. So I go to 2 on the x-axis and 4 on the y-axis. Plot that point. Since I know where 4 is and I know where 0x would be, I can go ahead and just go across there. Next thing I need to do is 3 on the x-axis. Well, that's one spot to the right. I know that this is 4 right here, so I can count 5, 6, 7, 8, 9, 10, 11, 12, 13, and make a large point there. What matches the 13 on the far left? Well, that would be -1. X being -1 being here. I need to go ahead and graph or connect my points to make my graph. Okay? Be careful with those as well. That should open up at the top. You should not have arrows that are starting to point towards each other. That would be incorrect. All right? Finally, I need to go ahead and find my domain. In this case, my domain is always all real, but yes, you need to write that every single time. And then my range. Since, again, it is opening up, my y is going to be greater than or equal to the y value for my vertex. So I'm going to take the y value for my vertex, plug it in here. That would be 1. And that is the end of our problems for graphing quadratics in vertex form. Remember, in order to find your vertex, we're going to use the opposite of whatever our h value is, and we're going to use the same as whatever our k value is. Our axis of symmetry is going to be our opposite of our h, or just the x value from our vertex. We want to put our vertex in the center of our table. As we move to the right, our x's get larger by 1. As we move to the left, our x's get smaller by 1. Then we need to take those x values, plug them into the original equation to find our y's. Finally, our domain and range. Our domain is going to be all real. And our range will be y is greater than or equal to our y value from our vertex if the graph opens up, and our range would be y is less than or equal to our y value from our vertex if our graph opens down. Thank you very much for watching the video, and have a wonderful day.